Let's share the share Microsoft Word. Share. So we are sharing this Microsoft Word, and then like to have okay, guys. Hope my pen is working. Final exam review. So the first topic here is in the final exam is sig fix. You'll be able to tell me if I give you a number and then what sig fix that might be. You should be able to do it, correct? For example, I'll give you one now, just one. A, we are determining the sig fix, 0.000010. So how many sig fix this value does have? How many? 6? Any other answer? 6? 6 is not correct. 2? 2 is correct. Why? This is a decorating 0. Those are locating 0 because they are missing the whole number here. If there is a whole number before them, there will be all of them significant. The only significant is the whole number, always significant, and the 0 after the whole number, of the last zeros. If two conditions are met at the same time, what those are two conditions? The zeros here they have to come after whole number, okay, and the decimal is present. So we have decimal is present. So the answer is 2. Correct? Let's do another one. How many significant figures we have? This is the decimal here. Okay, this is the decimal here. How many? How many? Can you see it? You can see it at all? Oh, it's down a little bit. Well, I can't go and take it because I'm recording. So maybe the number is here. I can write it here for you. Oops, sorry. 2.6010 10 minus 5. So how many sig fix does it have? How many? Guys, 4? That's not correct. So how many? 5? Why is 5? 5? That's correct. Why is 5? Well, this is whole number here, and this is whole number. All the whole numbers are always significant. The trapped 0 between whole numbers are always significant. The last zeros, they are significant if the two conditions are met. First, they come before them come whole number, and the decimal is present, and we have a decimal here. So the answer is 5. Okay, guys? The answer is 12. Now let's look at another one. I have, let's just see here. So how many significant figures do we have here? Come on, guys. 7, not correct. 2, not correct. 5, 8. Do we have to open an auction here? No. 5, 5, and a couple of people said 5. Whole numbers are always significant. Zeros after here, oops, sorry. Zeros will come after. If they have to be significant, they have to meet what? Two conditions at the same time. They come after whole number and the decimal is present. So those 3 are significant. How about this here? There's no whole number here in front of them. Make them significant. So that's missing. So this is the 0 is decorating. Those 2 zeros are locating. They are not significant. The answer is how much then? 5. Yes. No, not so. No, the answer is no. Unless you have, can I make this one significance now, all the zeros? Yes, easy. I put the same number here. Look, guys, I put the same number here. Then how about putting 8 here, a number, whole number. Now, are those all zeros are significant? Yes. What they are considered trapped 0 between 2 whole numbers. The whole number is succeeding in power the decimal itself. Are you following me here? So it's very important, the whole number. So now they are called trapped zeros between 8 and 3 whole numbers. Are you following me? So now how many we have here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 6, 6. Make sense? You need another example, guys? Another example? So how about this? Well, those are the same thing like 10 minus 5 in your previous. Those are not part of sig figs consideration. And if you have even the ln 2.0, whatever 3.0, those are not part of sig. Look at the number up front here. You guys? So any question about sig figs? Any question? Really what makes the zeros are significant always, not the decimal, the whole numbers. They have to be trapped, correct? Or the whole number comes before them. And the last zeros are always significant if they meet 2 conditions at the same time. If one condition is missing, then they are not significant. Are you following me here? So but suppose I have now, let's take this one out. Okay, let's take one you can very obviously how big or how huge the importance of whole numbers. So look at this example here. Okay. Can you see that? So now tell me what's the significance of the first one. How many? How many? 3.2? Correct. So this is significant because it meets the condition. The zero or those zeros, whatever, how many zeros here, we have only one zero is coming after whole number, correct? Everybody agrees? And the decimal is present. So this is 2. How about the other one? 1. Why is 1? Because there is no whole number here. It's missing. No whole numbers here. Only 1. How about here? How many? 7. Why? Well, that's whole number here. And all those zeros coming after whole number and the decimal is present. So the two conditions are met, correct? Because always the whole number will succeed in importance or priority the decimal itself. So how many here? 7. So let's go for the second subject. So I think we finished the sig fix stuff here. The next the next topic is we are looking for density. Now, the density here, as I said, density is the definition is D. Density is a ratio between mass over the volume. This is the main formula. This is main formula, correct? The mass in grams, the volume in milliliters in general. It depends on what phase you have. If we have, and this is the density, if you have liquids, then you have gram per ml. If you have solids, what's really is changing is your volume, centimeter cube. If you have gases, then it's the mass is not changing over liter. So liquids are gram per ml, solids are gram per centimeter cube, and gases gram per liter. Those are the units. Guys, those are the units. Now with this formula here, you can go and make 2 sub-formulas, which is always very important to have the main formula, memorize the main formula, and then you can work it out to the sub-formulas out of the sub of the main formula. So you have main formula, you can make sub-formulas out of it. So if you have determined the density, you'll be able to determine the mass. And the mass cross-multiply is density multiplied by volume. This is one of the sub-formulas. The second one is the volume itself, mass over the density. So now we have, those are um, sub formulas. And this is the main formula. This is the main. Okay, guys. Sometimes not give you the main, the problem will give you the main formula, will give you instead the sub formula. So you will always memorize the main formula, and then from there you can work it out. Okay, guys? For example, I'll take this one here, I'm recording, so you should be able to have everything is recorded. Let me take this one here out. So if I give you the density is say 2.50 gram per ml, and the volume is 250 ml, and you're asked to get the mass. The mass you don't know. Well, you don't have to memorize the subformulas. You have to only the main formula. V is M over V, mass over the volume. So the density is given to you, 2.50 gram per ml. The mass you don't know. And the volume is 250 ml. The ml cancels with ml. So cross multiply. Mass is 250 multiplied by 250, and the mass in grams, correct? In grams. So now you have to watch out your answer has to satisfy the sig fix rules. So this is how many sig fix? 3 sig fix. And this is how many? 3 or 2? I heard 3. 3 or 2? Final? Okay, it's sold for this price. So we are always, we have an option here. So this sold for this price. So it's 2. So our answer has to have how many? So answer has to have rounded off to 2 sig fix. I'm not doing the calculation, but at least just do the calculation and round the whole thing to 2 sig fix. So guys, is this following? Okay, so now we'll go for Lewis dot structure and Whisper. Okay, so Lewis dot structure and Whisper. So let me take this one out. I'm recording, so don't worry about this. I hope the voice is working. So I think it's working because I signed in my credential there. So okay, so suppose we have, and I told you have to memorize this small tiny the Whisper code, just about 4 or 5 of them, so not that many. So suppose I have here, give you the Lewis dot structure of NCl3. We need the Lewis dot structure of this. And so we need Lewis dot structure. Yes, yes, you can. Lewis. And we need to know the molecular shape. Okay, so we need to think about this. And maybe total VEs. So 3 things from this. Well, it turns because we have both of them are electronegative atoms, chlorine, nitrogen, and we have 3 of chlorine. Nature will not allow to put 2 electronegative atoms near each other. In some instances, nature will allow that to happen, like hydrogen peroxide, but those molecules are not stable. Anytime you have 2 or more electronegative atoms are near each other, they will fight each other because each one will try to pull out the valence electrons from the other neighboring atom. So the best thing is we have 3 of those. We'll keep them apart. We'll put nitrogen in the middle. Bless you. Chlorine here, chlorine here, chlorine here. Okay, far off from each other. Because just nature will tell you to do that because those are electronegative. If you put them near each other, molecule will not be stable. The molecule, those atoms, electronegative, they will fight themselves. And they will lead to instability in the molecule itself. So we put them out and look at the periodic table. The color here to blue. Nitrogen has 5. So I put nitrogen. Here it is 1. Here's 1. Here's 1. And here is 2 with each other. Those are 5. Correct? Group 15 or 5A. If you look at the periodic table, nitrogen in 15, group 15, or 5A. Fluorine in group 17 or 7A, so we'll have 7. So here it is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is 7 VEs, and this is 5 VEs, valence electrons, correct? Now we start always with single bond, always. If the single bond will not satisfy the octet rule, remember the octet rule, I gave you the octet rule. We'll go back and look octet rule. We have carbon, nitrogen, oxygen, fluorine. This is a must. Those are the only 4. They have to obey octet rule. All other elements or atoms inside periodic table, they can violate the octet rule. But those 4, they have to have 8 surrounding them. Bonding or non-bonding? Non-bonding means those unshared electrons or orphan electrons. So I'll do single bond here, single bond here, single bond here. The central atom has 1 set of lone pair. Those are the orphan. Those are called lone pair or orphan pair. Okay, or non-bonding pair. So lone pair, orphan pair, non-bonding pair. But all is connected. And all of them, they have 8. If you calculate for nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. For For chlorine, 1, 2, 3, 4, 5, 6, 7, 8. So octet rule is held for nitrogen. For us, is nitrogen important? Chlorine can sometimes violate the octet rule, that's fine. But nitrogen there, nitrogen has to have 8. So this is now the correct Lewis dot structure, which is NCl lone pair, Cl and Cl. And surrounding the Cl here, 7 plus 6, 6. So looking at this, I have to get the code. I have to memorize the code to determine what I'm dealing with, what shape of molecular. So this is A, this is another B, B, and B. And this is E, one lone pair. So I have the code is A, B, 3, E1. This is the code, whisper code. Whisper code. So that's the whisper code. So looking at the table you have, what will be that? Somebody will tell me? IP3E1. Bent? No, not bent. Linear is no. Trigonal planar is no. Tetrahedral is no. This will be trigonal what? Yes. Trigonal pyramid. Okay, guys, this will be trigonal pyramid. So this small tiny table I gave you with all the codes. You have to memorize. Those are about 5 or 6. Memorize them, and then you can determine from the code what the molecular, what they call it, the molecular shape is. Now, if I ask you for electronic, which is, we don't ask, what will be the electronic? What will be the electronic shape of this molecule? What's electronic will be? Remember, electronic will treat all those the same thing and will consider those lone pair, correct? So we are considering this, if that's this molecular, correct? The electronic here shape, then I have to consider all this connection will be A, B, 4. Forget about the lone pair, consider them as one group. A, B, 4, that will be what? Tetrahedral. Tetrahedral. Just this review, that will not come in the final exam. The difference between molecular shape and electronic shape, the molecular shape will not consider the lone pair. You have always difference if you have a lone pair on the central atom, difference between molecular and electronic. If you don't have lone pair on the central atom, the molecular and the electronic shapes are identical. Correct? Are what? Identical. Now they are not identical because you have one set of lone pair on nitrogen on the central atom. Therefore, the molecular is trigonal pyramid and the electronic is tetrahedral. As I said, this topic of electronic versus molecular will not come in the final, but just as a reminder, and we have covered it. Correct? Now, with this in mind, we have to calculate the total valence electrons. So how many? Somebody will tell me how many valence electrons do we have in this molecule? I mean, it's up to you. You can calculate the whole thing here. But the easiest one, look at this. You have one nitrogen, 1 multiplied by 5, plus. You have 3 chlorine, 3 multiplied by 7. So we have 5 plus 21, correct, is 26 VEs. 26 VEs, correct? 26 VEs. Now, but the angle, nobody will ask you what's the angle in between, but this is because of the fact that you have a lone pair set on the central atom. There will be a little bit deflection from the tetrahedron. Tetrahedron is 109.5, 19.5. This one will be a little bit less, around 107. But nobody will ask you about the angle, so don't worry about it. Okay, guys? So, any questions so far? Any questions so far? Any question? If there's no question, then we'll go for the next. What's that? One more of that? Yeah, we have more time. Okay, so you have any preference, any structure of your own? Look at any preference, look at anything inside the web or anything you want to see. Any, what's that? Yes, not all the elements. We have only 4 elements will obey the octet rule. We have carbon, nitrogen, then oxygen, and then fluorine. Those are the 4 elements. They have to obey octet rule. They have to obey octet rule. They have no other choice. If they don't obey the octet rule, means your Lewis-Dot structure is not correct. All the other elements, they can violate the octet rule, correct? Can I show you this? Well, no, that's not it, the exam, but at least I can give you. If you have one in mind, bring me one. Anything you want. Challenge yourself. Look at the web, any of those. Yeah, challenge yourself. Sulfur what? Sulfur and chlorine. Well, sulfur and chlorine, you can sulfur and chlorine SOCl 2, for example. Okay. Sulfur oxychloride. This is highly poisonous compound. It's used in I think in World War I and World War II. Highly poisonous compound. But how we get the structure, Lewis-Dot structure? Well, I know those, they have to be terminals because they are identical. They cannot be adjacent to each other. Okay? And the rule always will tell you to put the most electronegative always at the edges, unless there's no other choice, you can put it in the middle. But all in general, the most electronegative from all those 3 elements or 3 atoms, you have to put one of them, the most electronegative, at the edges. And most electronegative is oxygen. So I put oxygen here, sulfur here, one chlorine here, the other chlorine is here. Okay, so chlorine cannot be adjacent to each other. They are electronegative atoms and they will fight each other. So, and this is the most electronegative. It has 6. So you change the color here. 1, 2, 3, 4, 5, and 6. This one has 7. 1, 2, 3, 4, 5, 6. In each orbital, you have a maximum of 2 electrons. This is 7. This is 1 here. Okay, one here, and one here. Those are three, correct? Those are three. And one here and one here. Those five, but sulfur has six for the cis group. So I put here, that will tell me this one has to have a double bond. So this one with this, one single bond. Here is six here. 1, 2, 3, 4, 5, 6, and 7. So you can't see, but I will take it up. Just hold on. So now what I will do here, I made the two here, so I have to take those out. I have to take one of those out. I'll take those out and put them here. That's double bond. So now I have, can I take this one out? Can I take it out? Everybody has it? Everybody has it? No, yes? Yes, no, I'll just write again the structure of it. Okay, so the structure of it as this is oxygen. There's a double bond here. This is sulfur. There's one single bond, chlorine, 7, chlorine, 7. And you have 2 here. And oxygen, 2. Now you can see the sulfur, not the sulfur. Sulfur has how many electrons? Let's count them. Let's count them here. 1, 2, 3, 4, 5, 6, shared and unshared, 7, 8, 9, 10. Does it obey the octet rule? No, no obey the octet rule. Fluorine, it looks like it will. 1, 2, 3, 4, 5, 6, 7, and 8. Chlorine, and this is the same thing, 8. But we don't care about chlorine. It's just a tuner. We care about central atom. Central atom does not have 8. How about oxygen? Oxygen has to obey. Let's do 1, 2, 3, 4, 5, 6, 7, 8. This one obeys octet rule. The chlorine for some luck we have. But sulfur central atom does not. It has 10. It has what? It has 10 VEs. So no octet rule, no 8, shared or unshared. So with this in mind, what will be the structure of this? What's the shape will be? This is your A, central atom. This is B, regardless whatever B is. This is B, this is B, and one set of lone pair. So this is A, B3, E1. We just talked about it a couple of minutes ago. This is trigonal what? Not planar, no. Pyramid. Okay. How about the valence electrons? Well, it's easy. We have O, SCl2. Oxygen is 1 multiplied by valence electron 6. Oops, sorry. 6. Why is moving? Plus 1 multiplied by 6. Plus 2 multiplied by 7. So 6 and 6 plus 12 plus 14, 26. Total VEs. Okay, guys? Okay, so let's take another topic. The other topic is balancing chemical equations and the type of chemical reaction. So let's take this one out. Okay, so balancing chemical equations. So let's do okay. So we'll have a chemical reaction C6H14 plus oxygen give us CO2 plus H2O. Maybe C6. Okay, guys, let's balance this. So we don't need a table here, correct? No table. So what should I do first? No table. Do we need a table? No. No table. So what should I do next? What should I do? Carbon in the left side. Remember, this is your reactant side, left side. This is the right side, product side. Carbon is 6. So my intuition will tell you how about I add 6 here. Therefore, I have balanced what carbon. Hydrogen is 14. I have hydrogen is 2. So I have but what 7. So I balance now carbon, hydrogen balance. However, oxygen is not balanced. Oxygen is not balanced. So here I have 2. Here I have 6 and 2, 12. Plus 7 and 1. This is 1 understood, not taken. That makes 19. This is an odd number. This is an even number. So you have an odd and even. This is an even. This is an odd number. So in order to get this full balance, I have to go through what fraction? I have to. So I put the 2 here. So I can cancel to the 2 here. 2 and 2, they cancel themselves. And I put the 19 here. This is now balanced. However, it's not final balance because nature does not allow fraction. There is no fraction of atom, fraction of molecule. So this is now like this, mathematically is balanced, but naturally it's not. So I have to get the fraction out. So what I will do here, I will take the whole equation here, multiply it by what? By 2. So now the equation is 2 C6H14. The two cancels out, plus 19O2 plus 2 multiplied by 6, 12 CO2 plus 2 multiplied by 7 is 14 H2O. Now let's look if we are correct. 2 and 6 is 12 carbon, and here we have 12, so carbon is good. Hydrogen is 2 multiplied by 4 is 28. 28. Hydrogen is 14 multiplied by 2, 28. Oxygen is 19 multiplied by 2, 38 oxygen. Here we have 24, 12 multiplied by 2, 24, plus 14, 1 understood not written, 14, that will be 38. So 38 and 38, so this is balanced chemical equation. So what type of reaction is this? Combustion. So this is combustion reaction. Okay, guys. So, any question about this? Any question about this? So those type of will come in the final exam. So let's clear out. And let's look at the another type of chemical reaction, and you tell me what that really type of reaction is this. What type of reaction is this? What type of reaction is this? What's that? Guessing? So take your time. What type of reaction is this? Look, double displacement. Sodium will take this part here together, and the H with the 2OH to make H2O. So this is double replacement or displacement. Special name of it, what will be? What will be? Oh, guys, you did this in the experiment. Acetic acid, that's your acetic acid. What you did in the titration, what type of reaction you did? This is, we call it neutralization. Or titration. Acid-base titration, acetic acid. Vinegar. Okay, that's what you did. You titrate acetic acid and vinegar with the sodium hydroxide. Okay, guys, this is neutralization or titration. That's it's a specific name of it, but the whole name of it is a big picture of it is a double displacement reaction. So let me see here. How about another type of reaction here? What type of reaction is this? What's that? This is decomposition. You break single molecule or single compound in two or more compounds, correct? So can I take this one out? Can I take this one out? Has it? Has it? Now we'll go for stoichiometry of the solution. We'll ask about ourselves about. I have a compound. This looks like this one here. Okay, and I have 2.5 grams. I need to know, or 2.50 grams, how many moles of this can be calculated. Remember, I can weigh the mass in grams, but I cannot weigh the mole. The moles cannot be weighed. Instead, it's calculated. So how many moles? Somebody will tell me? Somebody calculated this? Well, it turns out to be, in order to calculate the moles, you have to know what the definition of moles. So the mole is a ratio between mass over molar mass. Very important. Okay, what we call this one here? I need the chemistry, chemical name, and the commercial name. What's the name of it? Chemically? Sodium hydrogen. Sodium bicarbonate, sodium bicarbonate, sodium bicarbonate, or sodium hydrogen carbonate. What's the commercial name of it? It's baking soda. I need to know what number of moles in 2.50 grams of baking soda. So I have the mass is given to me, and this is 2.50 grams. Correct? The molar mass, I don't know. So the molar mass is defined as what? The sum of all atomic masses of atoms involved in the structure of the molecule, correct? So you have one sodium is 23.0 gram per mole. You have hydrogen, 1.00 gram per mole. You have carbon, 12.0 gram per mole. And you have 3 oxygen, 3 multiplied by 16.0 gram per mole. So calculate all of this. How much is it? This is 48, by the way. This is 48. So you have 23, 13, 6, 3, and 48. The 6 here. That will be 48.0 gram per mole, correct? Correct me if I'm wrong. This is 6.3, correct? Plus 48. 48 grams. So here is 84.0 gram. 3 sig fix, and you get number of moles rounded to what? Okay, guys? The mass is given to you, 2.50 grams. You have to calculate molar mass. You have it there. You have the periodic table will be given to you. So you will be able to calculate this. Okay, guys? Yes. What's that? The periodic table will be given to you inside the exam. The first thing. Okay, now we'll go for the pH. Go for what? For the pH. Okay, so can I take this one out? Let's take this one out. Okay, so we'll determine the pH. So the pH of a solution. I will give you the OH minus concentration is say 1.63 capital M. Capital M is molar, means mole per liter or molar. Okay, or sometimes called just molar. So that's given to you, and you have to know what's calculate the pH of the solution. So how we do this? There are two ways to do it. Whatever way you like is up to you. Okay, the easiest way is to get the log of this. So the OH, then you see the POH minus log the OH minus log 1.63. Okay, so how much is minus log 1.63? How much is it? Somebody has it? How much? Negative what? 0.2. Negative and negative cancels out. 0.2. 3 sig fix, how many? 1. 3 sig fix, 0.210. Okay. Now, I have formula for POH plus pH equal 14. You have to memorize this. That's easy, okay? Now, I have this one here is buoyant 210. This one I don't know. This is 14. So the pH will be correct. 14 minus 0.210. Okay, guys? So it will be the 0, 0, 0, 0, 10, 9, this 9, 7, 7, correct? 7, and then 13. Now I have one digit after the decimal here. Here I have 3 digits. So I have only one digit after the decimal, correct? After subtraction will be, the answer is 13.8. The answer is 13.8. So this is sometimes have to match how to calculate this. The other way I can show you, the second way, but some students get confused about this way. This is the easiest way. The other way we can do it, can I take one out? The other way is if I can give you the OH minus 1.63 molar. So there is KW is 1.0010 minus 14 equal the H plus multiply the OH minus, correct? So those are together multiplied. So I have this one here. I can get the H plus. So the H plus is 1.0010 minus 14 divided 1.63. And then the pH is minus log the H plus, which is minus log the value of 1.0010 minus 14 divided 1.63. That would be the pH. Value, correct? Okay, so we are almost there. Now we have titration problem. So can I take this one out? Okay. Okay, so can I take this one out? Let's take this one out. And now we are looking at the buffer, I think. Okay, so now the buffer. What we said about the buffers, solutions, we use them to add them to our solution to resist change of the pH, the acidity or basicity of the solution. So is used to keep the pH of solution constant, does not change, correct? So, and sometimes we'll give you type of buffers, you have to look into it and then determine which is the buffer. So if I have HCl and sodium chloride, I have nitric acid, acid nitrate, and I have acetic acid, sodium acetate, I have ammonium hydroxide, ammonia. So it asks you what determine which buffer, which was of those four can make buffer. Yeah, the answer is more than one. So here it is. Sodium can be a buffer, yes or no? Answer is no. Why? Buffer is always made of what? Weak acid or weak base plus its salt, the conjugated acid or conjugated base. So this is strong acid. Let's violate the weak. This conjugated base is correct, but this is strong acid. Nitric acid, strong acid, strong. Acetic acid, that's weak acid. And this is conjugated base, weak acid. This is conjugate base or its salt. So this is a buffer. This has an acid here, weak acid. Ammonium hydroxide, weak base. And this is conjugated. In this term is a conjugated acid, not this, but hold on. I will just flip this one here so you'll not be confused. Ammonia is a weak base, and ammonium, this one here is conjugated acid, right? This is a weak base, and this is conjugated acid. Okay, guys, so those are type of buffer. You'll get a couple of those, and you have to determine which is which. Okay, guys? And we'll calculate the molarity for acid or base. Do some titration calculation. So let's do it. Okay, guys? Bless you. So we have the burette. Our burette is here. That's the stop coke here. That's the Almayer here. Correct. This is a 0 ml. This is a 50 ml. And this is our vinegar. So this time we'll take 5 ml. Correct. Just show you how to do the calculation. Correct. 5 ml. 3 drops of your phenol That's our indicator, organic dye. And then we added about 10 mL distilled H2O. Has nothing to do with the reaction, just to help us visualize the endpoint, the change. And this one here is 0.150 molar sodium hydroxide. Now the question is, calculate molarity of vinegar, of acetic acid, CH3COOH. This is acetic acid. Okay, guys. So, the pen here. So, how we do that? I have to know, it's missing one single piece of information. I know I have to end to the endpoint. Where is the endpoint? Suppose the endpoint is here. Endpoint, that's amount of the base to reach the color change, the endpoint called endpoint. So suppose this came out to be 7.50 ml. I need this piece here. So I did several trials, and the average is 7.50 milliliters. Correct? So first thing is to determine number of moles of my base. How many moles of my base are used to neutralize this acetic acid in vinegar? So I'll start with here, 0.150 mole, my sodium hydroxide per liter sodium hydroxide. And then I multiply the whole thing by the liter not milliliter, liter of the amount of sodium hydroxide used to the endpoint to change of the color. 7.50 divided by 1,000 is 0.00750 liter sodium hydroxide. Why I multiply? Because I take the liters with the liters canceling out. So up to here, I'm calculating number of moles. Then I go and look at the chemical equation. Acetic acid, 1 mole, will react with 1 mole of sodium hydroxide. Give you 1 mole of the salt, sodium acetate, and 1 mole of H2O. So everything is 1 to 1. So the next step is to get number of moles of sodium hydroxide out of my way. So 1 mole of sodium hydroxide cancels with 1 mole of acetic acid, so acetic acid from the equation. So I get moles of sodium hydroxide, moles cancels. Okay, I need mole per liter of acetic acid, mole per liter. So I have to divide the liter, which is, I used 5 mL. So 5 mL is 0.0050 liter acetic acid. Correct? Over 1. So 4 steps. Take the molar. First step, take the molarity of sodium hydroxide, you multiply it by the average endpoint value of sodium hydroxide. This way you can get number of moles. Look at the equation, 1-to-1 mole ratio, correct? The mole of sodium acetic acid will be at the top. And then you divide the whole thing here. You divide the whole thing by the liters of acetic acid. So the answer is, write it here, 0.150 multiplied by 0.00750 multiplied by 1 over 1, then 1, and then liters is 0.005 liter. Okay, guys? So, and this is, the moles comes from here. 1 mole acetic acid mole here. So, this way we can calculate what? We can calculate the molarity of vinegar. So you have to know how to calculate molarity of vinegar. Okay, guys? Now, out of this one here, how we calculate the percentage mass over the volume? Mass over the volume. Well, it turns out to be, you stop here, correct? Let me take here and then calculate mass over the volume. Can I take this one out? Somebody has it? So now we have to calculate the titration. We have to calculate mass over the volume percentage. You have sodium hydroxide was, say, 1.50 molar, correct? That's sodium hydroxide. And endpoint is 7.5 milliliters of sodium hydroxide. And we have to get mass over the volume for acetic acid. Well, first of all, as I said, you take the molarity of sodium hydroxide, you multiply it by the endpoint by the amount of sodium have you used to endpoint, correct? So 1.50 mole per liter divided by 0.00750 liter over 1. This is moles of sodium hydroxide, correct? And you have 1 mole of acetic acid to 1 mole of sodium hydroxide. More sodium hydroxide would cancel with more sodium, liter sodium. So if you get more sodium hydroxide, correct, then you have to use the molar mass of sodium hydroxide, get the mass. So mole is mass over molar mass. Well, the molar mass of acetic acid, CH3, COOH, 2 carbons, 2 multiplied by 12, 2 oxygens, 2 multiplied by 16, and 4 multiplied by 1.00. So 24 plus 32 plus 4 plus 60. So 60.0 gram per mole. So then the mass will be whatever moles you have from here, you multiply it by the molar mass, by the 60. So take this value here, multiply this value by 60.0 gram per mole. Moles and moles cancel out from the moles, and you get number of grams. And how many liter use of vinegar? We use 5 mils. 5 mils volume of vinegar is 5 ml. So whatever is mass here, grams, divided by this volume, 5 mils, multiplied by 100. So look at the calculation of mass over the volume percentage, correct? And then the last thing here, we have to look Can I take this one out? Can I take this one out? The last thing here is the equilibrium of the Lesch-Keller principle, shifting the equilibrium to the left or the right. So if you have, for example, you have ammonia here, nitrogen plus hydrogen. Okay, guys, so plus heat is 92 kilojoule. So, whoops. Now, what will happen? Don't know why it's disappearing the whole thing here. So if you add nitrogen, what will be the shift? You add Shift will be which way? Externally, you add nitrogen. Where will be the shift? Left or right? Nitrogen will add itself to where nitrogen is to begin with, at the left. So the left side will be more stressed. So the shift will be which way? To the right. Now, if you add hydrogen, hydrogen will be added to the left. The left will be stressed out. Yet again, the shift to the right. If you add ammonia, ammonia will add itself to the right. The right will be more side stressed. The shift will be to the left. If you add heat, the heat found at the right side. If you add heat to it, the right side will be more stressed out. The shift will be to the right. If you remove the heat by cooling, then the right side had missing one of its components, so the shift will be which way? To the right. If you remove nitrogen, the left side will be missing something, so the shift will be which way? To the left. If you take hydrogen, remove it, the left side will be missing something, so the shift will be to the left to compensate what's missed out of hydrogen. If you remove nitrogen, ammonia, then the right side, the side is missing something, ammonia, so the shift will be which way? To the right to compensate to whatever loss of your product, correct? I think that's all. It's very simple. 20 questions for 2 hours, guys. It will be very, very easy, I think. So not have to be worried. Any question now? I'll take any question you have. Any question? Any question? Any question? Yes. Whatever I covered those questions, I went through the exam itself, but different numbers. But the concept is the same. So we'll meet sharp 8 o'clock. You have to go to the bookstore to buy yourself Red Scantron. I will not have any Red Scantron. And 8 o'clock, the bookstore is not opening until 9 o'clock. So you'll be losing 1 hour of your time to wait. Some of your classmates are very generous. They will give you one, but don't depend on them to give you one. Are you following me here? Then I put another request. Please do not forget to bring your calculators. Every time I have a couple of students who forget to bring their calculators. You know you are going for the final exam, correct? So be ready, bring a couple of pencils, whether mechanical or old graphite number 2 pencils, bring calculator, working. I have a couple of those here, but those are on solar. So if they have not enough charged light, they might not work, properly. So that's what I have. I can't help with that. And I'll give a scratch paper. The same thing we did the midterm, correct? Okay, guys. Any other questions you have? Yes. Well, sometimes students are during the exam will black out. You forget everything, including your ID. That's the reason I tell you have to bring your ID. Okay, but at least you memorize yours. But if you go to the fall, it's better to have your ID ready. That's in the S building, not far away from here. 1 minute walking from here. 1 minute. Maybe if you are delaying, maybe 2 minutes walking from here. They will give it to you. Okay, guys? Okay, so then I will say good luck. I will see you Wednesday, 8 o'clock sharp. Well, you have yours.